Alright, 10.2.9, tangents. We're nearly done. Nearly done with chapter 2. What is a tangent? A line that touches a circle at a point. That point is called the point of contact, and it will always be at right angles to a radius. That's what a tangent is. So a tangent intersects the circle exactly once. That's right, it touches it once. Always perpendicular to the radius. And if I draw them from the same point, then they're going to be equal in length whichever side of the circle I go to. Another word we're going to have to use coming up soon is a secant. A secant is just a line that cuts a circle twice. You can also have a secant later on that will cut a curve twice when we get up towards calculus. One theorem for this exercise only, and it's a pretty straightforward one. The alternate segment theorem, Mrs. Kirby likes to call this the sailboard in the sunset. You can see there we've got a nice little sailboard in the sunset with a big sun setting behind the sailboard. Alright, the angle between a tangent and a chord is equal to the angle in the alternate or opposite segment. So that yellow one would equal that yellow one there is what they're arguing. Or indeed, if I use the blue one, that blue one there and that blue one there would be equal. The alternate segment. Let's see how we get that. Well, let's start by constructing a diameter through the center of the circle. And we're going to have it all the way to the top. I'm going to call that D. So we've got a tangent from point P touching at T. Makes sense to have it touching there. And if I draw a diameter in and then connect that diameter up to X, I know that that point's a right angle. I also know that the tangent is forming a right angle. Now, how is that going to help me? I'm just going to get rid of those right angle symbols for a minute. Let's have a look. Within the red triangle, if I continue that line and make it red as well, this angle there, the 90-degree right angle, and the third angle down here, alpha, together add up to 180 degrees. But what else do we know that adds up to 180? Well, the right angle, the alpha, and this other angle must add up to 180. Well, in the previous triangle, I called it angle dot. So therefore, that dot there must equal the dot up there. Well, Chewy, that's great. It works if you've got a diameter, but what about if we don't have a diameter, like the blue triangle we're supposed to be proving? Well, we just go back to our other theorems, don't we? Angles subtended by a chord at the circumference of a circle are equal. So that angle D is equal to that angle C. And that's all there really is to this one. Let's find an example and have a go at it so we can see how easy it is to use. Alright, so deep into the exercise. Question 10 from the problem solving. Should be pretty hard, right? Not a chance. Let's have a look how easy this is. What do we know? Well, I do know that this angle A is going to equal whatever the angle in the alternate segment is. Fair enough, that can't be too bad. What can we do to solve this one then? What do those lines mean there? Double dash, we must have an isosceles triangle. That's going to make this angle 55 as well. Oh, so those two plus the yellow angle, which is equivalent to A, would add up to 180. So A plus 55 equals 180. So how many degrees there are in a triangle? A plus 110 equals 180. A equals 70. And if we want the degree symbols everywhere, we can put it. 8 degrees is 70 degrees. It's really easy, this one, guys. Get stuck in. You'll be over and done with in no time.